Welcome. Today we'll solve a challenging problem involving successive differentiation of a trigonometric function with natural logarithms. Let's start with our given function. We need to show that if y equals a cosine of natural log x plus bsine of natural log x, then after successive differentiation, x squared y2 plus x, y1 plus y equals 0. Let's solve this step by step. First, we'll find y1, which is the first derivative with respect to x. We'll use the chain rule here. For cosine of ln x, we get negative sine of ln x times 1 over x. And for sine of ln x, we get cosine of ln x times 1 over x. To make our next step easier, let's multiply both sides by x. This gives us x. y1 equals negative a sine of ln x plus b cosine of ln x. Now we'll take the derivative of both sides. Using the product rule on the left side, we get xy2 plus y1. On the right side, we use the chain rule again. Simplifying the right side, we get xy2 plus y1 equals negative a cosine of ln x minus b sine of ln x, all over x. Here's the key insight. Notice that the numerator is the negative of our original function y, so we can write this as negative y over x. Finally, multiply all terms by x and rearrange to get x squared, y2 plus x, y1 plus y equals 0, which is what we wanted to prove. To summarize, we found y1 using the chain rule, multiplied by x to simplify, found y2 using the product rule, and recognized that the right side was negative y over x. After multiplying by x, we arrived at our desired result.